Hello and welcome to my 2212 Lab 3. The goal of the lab is to determine the distance dependence of the magnetic field and length, and to determine the off-axis magnetic field at a 45-degree angle. This will be done through aligning a ruler on a east-west axis, which allows for the x component of Earth's magnetic field to go to 0. Then, using a smartphone magnetometer, different magnetic field strengths were measured at different distances and averaged out to find the distance dependence, in addition to taking a distance in one direction and in addition that same distance in a perpendicular direction in order to calculate the magnetic strength at a 45-degree angle off of the axis of the magnetic field. The magnetometer found on my iPhone 11 used as the magnetometer can be located at this spot on the diagram. How we can calculate the dipole moment and distance dependence of the magnet can be through manipulation of the Biot-Savart law. Through numerical analysis, one can note that if you take the B and you equal it to a formula K times R raised to the N, and you take the natural log of both sides, you'll get a linearized expression of the natural log of the magnetic field versus the natural log of the distance. Through this analyzation of this graph, we can calculate the dipole moment of the magnet. Some assumptions that we must make in order to make this model work is to assume that we are solving in only the x direction, and we must assume that the n value found is close to -3, therefore we can assume that the r values would cancel. The magnetic field was recorded 3 times at 5 varying locations and put into an Excel graph of the natural log of the magnetic field in the x direction varying to the natural log of the distance. This created a trend line in which the slope equals the n and the y-intercept is equal to the natural log of the k value. These values can be used further to go and understand the measured formula. From this and the calculation derived earlier in this report, the mu can be calculated. The mu calculated was 4.27, and the n determined from the experiment was -2.755. This n is close to the -3 expected value. The next section of the experiment was to measure the off-axis magnetic field results. This is a measurement of the magnetic field when it is not on one of the x, y, or z axes. To determine this, the measurement in the x direction of 100 microteslas was measured, and that distance was then put out in addition perpendicularly to the east-west axis. This created a 45-degree angle from the magnet to the observation point, and there the magnetic fields were recorded. You must correct by the y component of magnetic field due to the magnetic north not being the true north. In addition to the off-axis magnetic field being calculated in the lab, we also were able to model the system on Python script and build a GlowScript model of the system interaction, and we're able to use this to get the predicted value of B at the 45-degree angle. There was significant difference between the magnetic field measured and predicted. The predicted value ended up being 5 times the measured value. This could be as a result of metal screws used in the wooden table that I was using, or electronic or magnetic interference from other electronic devices nearby.